Hey there, and welcome to your own personal deep dive. I know you all are interested in the future of sustainable technology, so today we're tackling a question that I'm sure you thought about. Can we make eco-friendly construction materials that are strong enough for, actual buildings? We're talking about replacing the usual suspects, like steel and concrete, replacing them with something renewable. And wood comes to mind. But how do you make wood sturdy enough for, skyscrapers, bridges? You get the picture. The answer seemed to be engineered wood. But the chemical processing involved kind of makes the whole thing, how do I put this? It kind of defeats the purpose. Environmentally speaking, I mean.
Yeah.
But there is some exciting new research hot off the presses this past August. It's from the Matter Journal. Very cool stuff. And we've got the university press release, too, so we can really break it all down.
Well, what's really exciting about this research is that it addresses something we've been struggling with for a while, this whole idea of sustainable building. We want to use wood, it's renewable, it's good for the environment, all that, but we also need it to compete with materials that, let's be honest, have centuries of engineering behind them. Engineered wood itself isn't new, of course. Plywood, particle board, we've been doing that for ages. But to get wood strong enough for serious construction, we have to manipulate its structure. And that's where the chemicals come in.
Because you're essentially forcing it to be something it's not, right?
Exactly. Imagine trying to force a shapeshifter to hold a form it naturally resists. It takes a lot of energy.
And that's not exactly eco-friendly.
Not at all. All that processing, the waste, the energy, it takes a toll.
It's like you're undermining the very reason you're turning to wood in the first place.
Right. So finding a way to make engineered wood without all that baggage, well, that's the holy grail.
Yeah.
And this research, this might be it.
Okay, here's where it gets really cool. Instead of changing the wood after it's grown, these scientists were like, hold on a minute. Why not engineer the trees themselves? So I'm sure you've heard of lignin. It's what gives wood that rigidity.
It's what makes wood, well, wood.
Exactly. So this team, they use gene editing, and we're talking seriously cutting-edge stuff, to create poplar trees. And get this, these trees produce wood with way less lignin. Imagine wood that's just naturally more flexible, easier to work with. And you don't need all those harsh chemicals to get it there.
Yeah. It's actually a brilliant example of biomimicry, taking inspiration from nature itself. Trees have evolved to balance strength and flexibility, but we often need to tip the scales, at least for construction. By reducing lignin, we're kind of giving the wood a head start, making it more, how do I put it, amenable to the shaping and compressing we need for those engineered wood products. And what's really neat, this whole reduced lignin thing, it actually translates to stronger engineered wood. It's kind of counterintuitive, I know.
So how's that work?
Well, remember how we talked about compressing wood, to increase its density and strength?
Yeah, like squeezing all the air out and making those fibers stick together really, really tight.
Precisely. But here's the thing. Lignin, with all that rigidity, it actually makes the compression process less effective.
Oh, really?
Yeah. It's like, imagine trying to compress a spring.
Okay. I see where you're going with this.
You can only push it so far, right?
Yeah.
Before it pushes back.
So with less lignin getting in the way?
Exactly. They called it knockout wood. Very catchy, right?
I like it. So did it work? Is it actually as strong as the stuff that uses all the chemicals?
That's the best part. They ran all these tests, kind of a supercharged version of particle board.
What did they find?
Well, first off, they found that this knockout wood, once they compressed it, it was 20% denser than regular poplar.
20%? Wow, that's a big difference.
It is. And get this. Compared to the chemically treated wood, it was just as good.
No way.
Yeah, and some tests, even better. We're talking strong.
No, strong.
We're talking rivaling some aluminum alloys in terms of strength to weight ratio.
Okay, now hold on. I got to make sure I'm following you. So we're saying that by changing one gene in a tree, we might be able to make a building material that's as strong, if not stronger, than what we use now.
Exactly.
But without all the environmental downsides.
You got it. And you know what's even more interesting? Especially for someone like you who's so into the future of tech and all, it's not just about strength.
Really?
Yeah. The researchers, they hinted at all these other possibilities, like improving wood's durability, its thermal properties, even its acoustic characteristics just by tweaking those genes.
So, let me get this straight. We could have buildings that are not only stronger and more eco-friendly, but also better at regulating temperature, blocking out sound. Come on, that's amazing.
Yeah.
It's like we've unlocked this whole new world with this knockout wood.
Mm-hmm.
It's like we've gone from just chopping down trees to, actually working with them.
Mm-hmm.
And the best part is, we're just getting started.
Right. I mean, if we can do this, what else can we do? Imagine buildings that are just naturally fire resistant because of their genes. Or how about structures that are resistant to pests so you don't need all those pesticides?
It's incredible when you really think about it. We could grow the materials for our future cities. And it would actually, help the planet instead of hurting it.
And it's not just about building up either. This could change how we do construction in tough places like disaster areas or even space.
Space.
Lightweight, super strong structures made from renewable resources, grown right there on site.
Okay, now that's just next level stuff right there.
It is pretty wild.
We started with this research paper, and now we're talking about a whole new future. Who knew that changing one gene in a tree could lead to all this?
That's science for you. It challenges how we think about things, opens up all these crazy possibilities.
Well, if you're as mind blown by this as I am, make sure you check out those show notes. We've got links to the research article and that press release so you can really dig in. And that just about wraps up our deep dive into the incredible world of, chemically free engineered wood. It's a mouthful, but it's pretty amazing stuff. Until next time, stay curious, everyone. And remember, the future of sustainability. It might just be growing right before our eyes,